Pratibha College of Commerce and Computer Studies, Chinchwad, Pune, organizes a certificate course in the Basics of Statistics organized by Department of Statistics. The objectives for this course are to familiarize the beneficiaries with the concept of basics of statistics and the methods to measure them in manually as well as statistical software. The beneficiaries are all streams: undergraduate, postgraduate, researcher, industrialist, government employee. The outcome from this course is, at the 38 course, beneficiaries will be able to understand and calculate the measures of central tendency, understand and calculate the measures of dispersion, understand and calculate the correlation between two variables, fit the simple linear regression line, calculate the descriptive statistics correlation and a regression in R software. I, Dr. Jayashree, welcome you for this certificate course in Basics of Statistics, Model number 5, Descriptive Statistics with R software, presented by Dr. Jayashree. The course content for this module is R software commands in central tendency, dispersion, correlation, and regression. So welcome to the R software. This is the logo for the R software which you download from the internet, which is available, which is for the free download for Windows. So first we will see measures of central tendency R commands. The basic commands required for the measures of central tendency are total of observation, that is sum of x, number of observations in x, that is the length of x, logarithm to the base 10, log of 10x, which is useful for the geometrical mean. To display the output, we are to use the cat command. To generate the functions having the repeated element, we use the command as rep. To create a vector for the given variable, we use the command c, and numerical values separated by comma. To create a vector in sequence, if it is available, then we have to write seq, start value, end value, and step value, or one can use the colon symbol to enter the vectors for the sequence. We use the mean command, mean of x command for the arithmetic mean, median of x for the median of the variable x, and there is no such command for the mode. Now we will see one by one the measures of central tendency for ungroup data, group discrete data, and group continuous data. So first we will see the ungrouped data. For the ungrouped data, let our example be for the observations 12, 15, 15, 16, and so on up to 20. Calculate arithmetic mean, geometric mean, harmonic mean, median, and mode. Now the R command for this value R, we enter the observations by using x is equal to C of all observations, and then we take the output by comma. In R, two commands are separated by semicolon. Then we assign the length of all these observations to the variable n. So that one we will copy and take to the R software. So here is the empty console that we have to use for the calculation purpose. When we run both the commands, you will see using Control R command, you will run the given R commands. So x is equal to c, so output you will get on one line with the bracketed 1. Here output line it is there. So here the length of the given observation is 17 for the given observation. Then we will write the R code as arithmetic mean is equal to arithmetic mean of x, geometric mean. For the geometric mean, we have to use the command lx is equal to log of 10 of x. We know that for geometric mean, we have to take first log of all value observations given to you, and then we assign this value. Then we take 10 to the power mean of this lx, and we get the geometric mean. Harmonic mean, which is n upon sum of 1 of x, and then we take the printout of it. Then we calculate the mode. There is no actual command for the mode, so for that we have to create a table of values of x. This table gives you the number of observations which is repeated how many times. Then we assign the value of the observation which is having maximum time occurrence. So that command which tx is equal to maximum of tx, this value is assigned, and using sort unit x command we assign the observation which is occur maximum number of times, and we get mode. Mode is equal to stx of bracketed square bracketed m, and we take print the median by the method med is equal to median of x semicolon me, and we take printout of all these observations for the given calculations. Now we will run all these values in the R. So here we take all values and we select all observations at a time and press the Ctrl R button to run all these commands. We will see that the Ctrl R runs the command. Here you observe that the arithmetic mean for the given data is arithmetic mean for the given data is given to you as 15. Then you will get the geometric mean as 15.137. Then you will get the harmonic mean as 14.98395. More you will get 15 for the given problem. So that way you will get all values for the given command. So a printout you will get all for all the observations. So this way we will run the R command for the ungrouped data. Then for the group discrete data, we will take the example following is the frequency distribution, and for the given frequency distribution we have to calculate arithmetic mean, geometric mean, harmonic mean, median and mode. The code for the given data you will get it as the group discrete data. The problem will take. So here the values of x are in a sequence 1, 2, 3, 4, 5. So here I assign the vector for x as x is equal to 1, 5. Values of the frequencies are not in a sequence, so we have to use the combine function to enter the value. Then to calculate the value of total of all frequencies, we are using n is equal to sum of n. So and arithmetic mean formula repetition function we use to make the table of x and f value. We use y is equal to REP of x comma f. Then we take arithmetic mean of y. Geometric mean that we calculate for by taking log of 10 of y, and which is assigned to Ly. So we take geometric mean using this Ly. Then for harmonic mean we divide the total divided by sum of f upon x, and again for the mode we will find the value of frequency which having maximum value here, which f is equal to maximum of x we are assigning, and the mode takes with that have a corresponding value by taking mo is equal to f of square bracketed m. For median, we are taking the median of y observation as it is, because in y all the values of x and f are stored. Now we will run these commands in R and take the output for the given data set. So when we run it, we will get the median as 3, mode as 2, harmonic mean as 2.099, geometric mean as 2.41, and arithmetic mean as 2.71. So this way you will get the median for the given data set. This is the R code for the given data set. Now we will go for the group frequency distribution table. So group frequency distribution table where class intervals are there. So we will run and we have to calculate for this data set the given values. The R command for this group data set is, we will write here lower boundary and upper boundary we have to assign to two variables. One is LB and another one is UB. Frequencies are assigned to the f value, and for the geometric mean harmonic mean, arithmetic mean, we require the class mark or the mid value for the data set. For that we use the command x is equal to LB plus UB divided by 2. Then we use the arithmetic mean sum of fx upon n, geometric mean 10 to the power sum of all these observations, sum of f into log of 10x divided by n, and harmonic mean is equal to n upon sum of fx. We know the formula for arithmetic mean as summation of fi xi divided by capital N. Geometric mean is equal to 10 to the power summation of fi xi upon n, harmonic mean which is equal to n upon sum of f upon x. So that way we have to assign all values for the given data set. Now here the important part is that we have to calculate for median we require the less than cumulative frequency. So less than cumulative frequency we calculate using the function cum sum. In sum of the f we are taking there. For median we require the cumulative frequency value which is just greater than or equal to n by 2. So we assign this value as Cf is equal to minimum of which LCF is just greater than or equal to n by 2, and then we use our regular median formula. Median is equal to lower boundary of the median class which is denoted by LV of Cs plus n by 2 minus the cumulative frequency of the previous class of the median and into h upon f into Cf. So this way we will run the median. Then for the mode we require the class interval which is having maximum frequency. We find that value by Fm is equal to which f is equal to maximum of f, and then we write the mode formula as L plus Fm minus Fm. So Fm we write for the Fm we write f of Fm. Fm then we find we want the pre-modal frequency, so that one we assign by the equation f into f minus 1. So it is Fm minus F1 divided by 2 into Fn minus Fm minus 1 and Fm plus 1. So that way we are assigning the post-modal value. And then we are taking printout of all these observations. Now we copy all the commands and run these commands in the R. So these are the commands. So from LB we have to run all the commands for the given data set. When we run all these commands in the data set, you observe that the sum of the all frequencies is 200. Then here you will get the cumulative frequencies for all the observations that you will get. Then you observe that mode is 445.71, median is 444.44, geometric mean is 443.6595, arithmetic mean is 443.9. So this way you will get the measures of central tendency for the group continuous data. So these are the method that is the procedure we have to use for the quick review. All these commands we have run in the R software. So these are for group discrete data. Then we go for the printout of these commands. Then we will now see the R command for measures of dispersion. In the measures of dispersion, we are covering a range, quartile, then mean the deviation, about mean, and standard deviation, absolute measures of dispersion, and the relative measures of dispersion we have to consider. For this we require the command as largest observation for the range which is taken by maximum of x, the smallest observation which is minimum of x, and the next command we require for the quartile is quantile x comma partition value in decimal 1. So suppose we have to calculate the first quartile, we will write it as 0.25, second quartile or median if we want we write it by 0.5, and third quartile we will write it as 0.75. Variance for the population we calculate using the command var of x. Standard deviation, we know that it is the square root of the variance as we studied in the model number 2. So that square root of variance we will take, or variance to the power 0.5 you may select also. So that is also the command. Then for the absolute for the mean deviation about median we require the absolute value. So that absolute value of x we will select. So we go for the ungrouped data. For ungrouped data, we are taking the example as calculate a range coefficient of range quartile, interquartile range coefficient of quartile deviation, mean deviation about mean, variance, standard deviation, coefficient of variation for the observations, and the observations are given to us. Now, the R code for the given data set is x is equal to C. We enter all observations for the given data set using the x1. So the values we have to consider. So we will take all values for the given data set and we will enter the values as measures of dispersion. So these are the values. First we will do the calculation for the range. So we copy data from the Word file and here we will enter the coefficient of calculation for range. So calculation for range, we will go up to the range. So we run all these commands. You will see the range for the given observation is 57. The observations are there. Using maxx command, we find the largest observation, which is 67. Using sx command, we minimum observation will get the smallest observation by the given formula, and range we calculate by the command lx minus sx. So this way you will get a range for the given data set. Then we calculate the quartiles. So here one coefficient of a range is remaining. Coefficient of a range, you will get it as range divided by, in bracket we have to write lx plus sx, so that we will add and then we will take the print of it or display of it as coefficient of a range is equal to, we will write it as COEFFR. Our software is very case sensitive, so we have to take care that what is typing in capital letter, small letter, according to that we have to consider for the given data set. Now we will run the command in R. We will see that coefficient of range for the given data set is 0.7. Calculate the range for the given data set. The R code for the fast review is given like this. So range, now we will see the calculation for the quartile. So first quartile, third quartile we require for the quartile division. So here we do only calculation for Q1 and Q3. Then coefficient of quartile by the formula Q3 minus Q1 divided by Q3 plus Q1, and then we will take the output of all these or display of all these values. So we will take the review from this, we will copy the command in R from the Word file for quartile. So that one you will get it as, so these are the commands that you will select all the commands and press Ctrl R, you will get the output. So you observe for the given data set, first quartile is 25, third quartile is 48.25, the coefficient of quartile division is 11.625, coefficient of quartile is 0.3174. This way you will get all four values for the quartiles. Next we have to see for the given data range the mean deviation. Here we calculate the mean deviation about mean. So for that we have to calculate the arithmetic mean by the formula mean of x, and then we use the command for the mean deviation, formula sum of absolute value of x minus arithmetic mean value divided by capital N, divided by small n. So that way we have to assign for the given data set. So we will copy the command from and we run all these commands in R. First we copy the command and select all the commands what we type and run the command using Ctrl R. So you will get mean deviation about mean as 1.242 for the given ungrouped data set. After this, we have to see the output for the calculations for the deviation and variance. So for variance, we have to use the command var of x. Then from this, we will calculate the sample variance by the formula n minus 1 upon n into population variance. Then we take square root of the var of x to find the standard deviation of the sample. Then we calculate coefficient of variation by the formula CV is equal to SDX into 100 divided by ABS absolute value of arithmetic mean, and then we will take the printers of all these observations. So for this we will copy the command in the R and write all the values in R. So here, when you select all the commands and press the Control Arc button, you will get the values for the given value. So this way we will get output for the given data set, and that one we have to consider for the given value. So this one we will run for the given data set and calculate the value. The coefficient of variation, we will get it as 42.73210 for the given data set. So that one we have to calculate and we will get the output for the given data set. Next one, we have to see the measures of dispersion for the group discrete data. The problem is find deviation, quartile deviation, coefficient of quartile deviation, mean deviation, about mean, coefficient of variation for the following data set. So number of poles scored in the match are given to you, which are in sequence 0 to 4, and number of matches, that is the frequencies, are given to you associated to the discrete data 25, 9, 8, 5 and 4. The command for this data set, calculations for the quartile deviation, in R we assign the variables to the x as x is equal to 0 to 4. Then we enter the frequency value by assigning f is equal to c of 25, 9, 8, 5, 4. Then we take sum of all these observations. The values of x and frequencies are stored in the variable y using the REP command. Then we will take arithmetic mean of y using the mean of y function. Then we find the first quartile of y using the quantile y, 0.25. That way we have to write it. Then second quantile we will copy it by y, 0.5. Third quartile y, 0.75. So this way we will write the command for the given data set. Now we will run all these commands in R. So that one you will get it as, for the given data set, you will copy all the commands and paste in R, and then we select all the values and run this command in the R. So here the first quartile is 0, third quartile is 2. The difference between 2 and 0 is 2, divided by 2 we will get 1. So coefficient of quartile deviation we will get it as 1, and coefficient of quartile, that means 2 by 2, you will get it as also 1, because it is 2 minus 0 divided by 2 plus 0. So it is 2 by 2, that is equal to 1. So you will get answer as coefficient of quartile as 1 for the given data set. Then we go for the mean deviation about mean. So arithmetic mean we will enter by mean of y. Then we find median of the given data set by median of y. We measure the mean deviation about arithmetic mean by the formula sum of f into ABS of x minus arithmetic mean upon n. ABS is used for the absolute function. Then mean deviation about median, we assign MED is equal to sum of f into absolute value of x minus median divided by n. Then we take the output or the display of it by the cat command for the mean deviation about mean, mean deviation about median, and then we have to run these commands in the R software. So we run now, do the calculation. Now hash command is used for the comment in R. So to write any command or to understand what is the calculation, for that purpose we are using the hash command, and when we run all these commands in R, we will get the Mean deviation about mean for the given data set is 1.11. Mean deviation about mean for the given frequency distribution, we will get it as 1.075. So this is about the mean deviation about median. Next, we have to see standard deviation and variance for the group discrete distribution. So here we use the command variance of x, which is equal to sum of f into x minus am to the power 2 upon n, standard deviation by SDX, variance of x to the power 0.5. Covariance for x is, which is write it as SDX into 100 divided by ABS of the arithmetic mean. And then we take display of the variance, standard deviation and coefficient of variation for the given data set. For this, we will copy again all commands and run it in the R software. So we will get the variance of the population for the given frequency distribution as 1.7354, standard deviation as 1.3173, and coefficient of variation is 119.9756. So this way we will get the standard deviation, coefficient of variation, and variance for the given data set. Next one, we will see the measures of dispersion commands for group continuous data. So first we will see for the frequency distribution. Following is the frequency distribution of size of holdings of a farm. So we have to calculate for this farm as quartile deviation, standard deviation, variance, and coefficient of variation. Also we have to calculate mean deviation. So this is the data size of holding in the points in the continuous. This is the continuous data. As we see, the upper limits of the first class is same as the lower limit of the next class. So these are the continuous classes for the given work and number of farms. That means frequencies are given to you 1000, 2300 up to 520 for the last class. So for that, first we will see the calculation R commands for the quartile. So we have to enter for the lower boundary 2.5 to 8.5 as the lower boundaries are in sequence and the gap between the two lower boundaries is of 1. So here step function we are not adding. Upper boundaries it is 3.5 to 95, which are again are in sequence. Then we are entering the class width of the class intervals as h is equal to 1. Then we enter the frequencies for the given class intervals using the C function or combined function. Then we calculate the mid value of the x is equal to L, the mid value of the class intervals by LB plus UB divided by 2. We take sum of all frequencies by SUMF command. Then we have to calculate the less than cumulative frequencies. So we use here sum function. Now for the first quartile we find the cumulative frequency which is just greater than the n by 4, because n by 4 means the 1/4 part of the given observations, that means the first quartile. So here we write the command as minimum which LCF is just greater than or equal to n by 4, and then we will see the formula for the coefficient first quartile, that is equal to L plus n by 2 minus LCF CF minus 1 into H upon CF minus 1. Then we go for the third quartile. For the third quartile we will find the CF3 value minimum which LCF is just greater than 3 into n by 4, that we have to see. Then we will write the formula for the quartile deviation and we calculate quartile deviation by Q3 minus Q1 by 2, coefficient of quartile deviation Q3 minus Q1 by Q3 plus Q1 formula. And then we take printout of all the values. The R commands in one take are given as, these are the R commands that we have to enter in the R script, untitled script, that we will select where error terms are not present. We are not getting any error terms here. No output we are getting, so easily we will copy it and paste in the another format or Word format. So when we run all the commands, you observe that the lower boundaries, upper boundaries are all assigned and we get First quartile value as 4.447826. Third quartile value we will get it as 6.641176. Coefficient of quartile deviation we will get it as 1.096675 and coefficient of quartile we will get it as 0.197751. So this way we calculate quartile deviation in our software. After quartile deviation, we had to calculate mean deviation. Here we calculate mean deviation about mean. So here we had to calculate. We had to use the formula mean deviation about mean is equal to sum of f into absolute value of x minus am upon n, and we take output for the given data set. So we look the commands for our commands in one. Look as this one. We copy all these commands and paste all these commands in the R editor, and from the R editor we will run the command using Control R. You will get mean deviation about mean as 4.466426. So this is the calculation of the mean deviation about mean, that is the measures of central tendency. After mean deviation, we calculate variance and standard deviation for the given data set. So we enter the lower boundary, upper boundary, class width, then frequencies assigned for the given data set. Mid value we will calculate, then sum of all observations. Arithmetic mean we have to require for the standard deviation and variance. Variance formula we write it as sum of f into x minus n to the power 2 upon n. Standard deviation, we use the square root of the v. So here we use the command sqrt, not to the power 0.5. Xqrt is another command to take the square root of the given observation. And then we calculate coefficient of variation by the formula hd into 100 divided by absolute value of arithmetic mean. Then we take print of all these outputs for the given data set. Now we run all these commands for the given data set in the R, and we paste all the commands in the R editor. When we run all these commands using Control R button, we will get variance for the given data set as 2.40, standard deviation we will get it as 3, and coefficient of variance we will get it as 53.9153. So that way you will get the value for the given data set. So if you get any type of error in the problem, you can edit the data set in the R editor and again select all the values and run the command. Here there is an error for the sqrt of v only, but v I am assigning by the vx. As I told you, the R is very case sensitive, so it will make difference between v and vx. That's why we will get error here. When we correct it and again run it, you will get the variance for the given data set as 2.403077. Standard deviation as 1.553, coefficient of variation as 27.858667. The next we have to see as the correlation. Correlation is the linear extent of between the two variables. For the correlation, the command required for the given data set is the data frame variable 1, variable 2. What are the variables that we are using that we have to keep in one table? So that table we will create by the data frame command. Then to print the data set or to print the table, we have to use here print command. We require to plot to get the idea about the given values of variable 1 and variable 2. We are using the plot command, where variable 1, variable 2 is their x lab. That means what are the values we want on the x axis. Y lab means what are the values we require on the y axis, and main means the title for the given scatter point. So for that purpose we are using main. Then next we write covariance between two variables by the formula COV, variable 1, variable 2, that we have to require for to find covariance between two variables. Correlation between two variables we will calculate using the formula COR. variable 1 and variable 2. So these are the commands. Now we see the example where for the example, we are calculating the coefficient of correlation between two variables x and y. So for this correlation between x and y, the R commands are x and y values we are selecting using the C function. So x and y values we are assigning the plot function we are taking. So here it is x and y variables. These are the two variables. As the graph is for the scatter diagram, so I am writing main is equal to scatter diagram. On x-axis, if I am selecting marks in subject A, on y-axis we are taking marks in subject B, and then using CORRXY, I am running the command XORXY. Covariance between the two variables, I am using COVXY. COVXY command I am using here, and then I am taking the display of all the values using the cat function. One is for covariance and another is for the covariance. So we have to now run these commands in R. So to run the commands, we will select the commands in the R editor and press the Ctrl R command. You will see here scatter diagram is present. So heading you will get from the main command of the plot diagram. On x-axis we will get marks in subject A. On y-axis we will get marks in subject B, and these are the dots we will get using the corresponding values of x and y. So covariance between x and y, we will get it as 242.244. Correlation coefficient, we will get it as 0.6511. That means there is positive correlation between marks in subject A and marks in subject B, that is x and y. So this way we will run the command for the correlation in R. Let's look at quick view for the commands in R. So these are the commands that we have to run for the correlation between the two variables. So next one is simple linear regression model, which is completed in model 4. So commands required for the simple linear regression model are LM command we required. LM command gives you the linear model. A dependent variable, generally we will take dependent variable as y and independent variable we will take it as x. Then to assign the values of the coefficients, that means intercept, and the coefficient of regression, we use COEF command for the variable. That is, we will take generally the variable which is assigned to the LM function. Then matrix of these variables we are assigning here. So matrix, the format is matrix data comma n row. How many rows we require? N row means number of rows. N column means number of column we require. If we want the matrix by row, that means first it will type row that way, or if we want by column, so that one we are using. So now we require the command using by row, and what are the dimensions we require, that one we are calculating here. So this is the problem for the given data set. So for the following data set, fit the regression model of y on x. A and B values are given to you. So these are the values we require, and we calculate the regression coefficient between the two data sets for the given values. So we assign x variable, assign the values by C function. We assign the values of y variable, B variable for y2 using C. Then here we use the output of the LM command to the LR. Then the coefficient, whatever we get, intercept, and the coefficient of regression value that we are assigning to CR using the COEF function. Then we get the matrix value for CR. Now we have to write the regression equation for the given data set. For that one, we assign the intercept value to A. Then the coefficient of regression value we are assigning to B, and then we take the estimated value for the given data set, and then we run d1 data dot frame x comma y estimated value of 1. Then we print the d1, and we write the equation using the conditional function if the regression coefficient p is greater than 0, then we write the regression equation a is equal to a plus b into x. If it is not, then we write the equation as equation of regression line a minus b into x. So that way we have to assign the given data set for the given data values. So that one we will assign now to the given data set. So we select all the values and run it. So here we are not select all the values. So you will get the equation for the given data set for the given problem the as the command for the R is not completed here. So you will get error for the given data set. So this way we will run our commands in R. So this is again for the fast review the code for the given data set. So this way the equation for the given data set is formed. Now the feedback link is shared in the chat box. This is the feedback link, and the quiz link is also shared in the chat box. So that way we have to do it. Thank you. Thank you for attending the lecture of the Model 5 of certificate course in Basics of Statistics. Thank you.